have that capability now. I'll give that a second. And so welcome everyone to the CCRM presentation for June. What we typically do is have all the participants just do a very quick self-introduction, your name, affiliated organization, and maybe a quick little blurb on your interest in risk or risk management. We'll run through the list. I will then give an overview of the Center for Catastrophic Risk Management. I'll introduce the speaker, and then I'll hand the reins over to Hamed and let him go to town on the presentation. So I'm just going to go down the list that I see in front of me, which is ever changing. But at the top of the list, I see Ian Mitroff. Ian, you want to go first?
Yeah, Ian Mitroff, a member of CCRM, and my primary interests are crisis management, philosophy of science, complex messy systems.
All the easy stuff, right, Ian? Yeah. All right, next on the list, I see George Lane. Welcome, George.
Yes, sir. Can you hear me?
Yes.
Okay. Yes, I'm George Lane. I've worked with Arun for, several years in remote detection of hazardous chemicals, primarily in the California area. We got a grant several years ago from the California Office of Homeland Security to conduct this work, and we continue.
Great, thank you, George. Bing, welcome, Bing Chen.
Oh, hi, Run. Hello, everyone. This is Bing Chen. I'm a professor and Arctic research chair in marine and coastal engineering, environmental engineering, working at the Memorial University of Newfoundland in Canada. I was the visiting professor with the center back a few years back, 2016, I think. And I'm now affiliated faculty. So my research area is more related to emergency response, especially caused by chemical or oil spills, and also how to mitigate, respond and mitigate the impacts. Yeah, thank you.
Cool. Nothing bad can happen in the Arctic, right?
Oh, finger crossed. We don't know. Frankly, that's a big concern. I just came back from University of the Arctic meeting. I think there's a strong concern there because of growing activities from the shipping, on energy industry, and also the human communities. Yeah, that's definitely a big topic there.
Well, great, thank you. Emery Rowe, you are next on my list.
Hi, Hamed, welcome. Good to see you again. Paul Schulman and I are working on a project now on the magnitude 9 earthquake scenario for the Pacific Northwest. So it's kind of interesting, particularly relooking the low consequence, high probability category.
Cool, thank you, Emery. Eric.
Good morning. My name is Eric Rao, and I'm a practitioner rather than an academic, but I work for the state of Oregon for the Oregon Office of the State Fire Marshal as an emergency response planner, dealing with not only fire, but also hazardous materials response, and indeed earthquakes, which is how I bumped into Emery and found out about these webinars. So I appreciate the introduction, and I'm here to learn and to listen. Thank you for your time.
Great, thanks, and welcome, Eric. Esfandiar.
Hi, good morning, everyone. It's Esfandiar Imani. I have more than 25 years of experience in the energy sector. The last 10 years, I would say, specifically on risk management. Currently, I'm with Safer 3 Corp, working with Ruan on risk reduction, resiliency, and reliability in terms of consultancy and education.
Silly things, risk and resiliency and safety, right? Okay, Kathy Schaefer, welcome, Kathy.
Hi, everyone. I'm a researcher working on a PhD at UC Davis, and my interest is in natural disaster risk, and particularly in the area of flood control, flood risk management. Thanks.
Welcome, Kathy. Thank you. Mark Nichols, you're next on my list.
Okay.
Are you with us, Mark? I'll cycle back to you. Otherwise, I'll have to make up the self-introduction for you. Paul Schulman. Did we lose Paul?
Can you hear me now?
There we go.
I go from one extreme to the other.
Holy moly.
I'm Paul Schulman. I'm connected to CCRM. They may deny it, but I sort of claim it. And I've, for more years than I even want to think about, have worked on researching organizations that have to be highly reliability and hazardous management of hazardous systems. And now I'm working with Emory in a domain where basically the concept of reliability itself, let alone high reliability, may not have any meaning whatsoever. So it's kind of an interesting shift for me.
Hey, that sounds like fun, Paul. Peggy.
Rune, Peggy, she has audio problem, but she put something on the chat box.
Oh, okay. No audio today. I'm a program manager with the Department of Interior Bureau of Reclamation, where we employ risk-informed decision-making for high-hazard civil structures. Cool. Well, welcome, Peggy. Peter, you are up next.
Hello, everyone. Peter Martelli. I'm an associate professor of healthcare administration at Suffolk University, a longtime CCRM member, and I've been working. I'm on sabbatical this year, so I've been doing a lot of international work. First in Georgia, the country, and in the spring a lot in France, and that's raised a lot of very interesting ideas. But many of these projects are around patient safety in hospitals and medical simulation training.
Cool. Peter, are you impressed and amazed at the thoroughness of safety that is pervasive throughout the world for patients?
Yes, I am. I'm impressed by it.
Great. Tony. Tony up there. I see you're on mute, Tony. There was an unmute and then a mute. I think I can unmute you. Maybe not. Tony, I'm going to cycle back to you. I'm going to go back to Mark to see if Mark now is able to unmute and introduce.
Great.
Mark, are you there? I think I heard you.
Well.
Yep, you're on. We hear you. All right, going. Tony, you're up next.
Okay, am I unmuted now?
You are good to go, sir.
Okay, I'm largely retired from, I am retired from response and mitigation in police and civil crises, and have enjoyed many years sitting in with CCRM. Thank you.
Good to hear your voice, Tony. All right, I guess that leaves me. I don't think I see anybody else on the list. So my name is Rune Storson. I'm currently serving as the executive director for the Center for Catastrophic Risk Management. My research interests lie in safe and reliable critical infrastructures. So I don't think we had anyone else join. I'm going to move on to a little background on the center. So the Center for Catastrophic Risk Management was founded back in 2005 in the wake of Hurricane Katrina, where a group of global applied researchers from academia, government, and industry who've come together to develop pragmatic solutions for the complex, multi-jurisdictional, messy problems of the 21st century. We conduct fundamental research on catastrophic risk through empirical data. By identifying and engaging targeted teams whose expertise are uniquely tailored to each challenge, CCRM aims to make the mess more manageable. And I'm excited today to introduce our speaker. Hamed is a management consultant with 12 years experience in sustainable business transformation, risk and reliability assessment, and management, project execution, performance improvement, and client relationship management for a variety of industrial, professional body, and government clients. His experience with capital projects covers offshore and onshore oil and gas, natural gas liquefaction, chemical process, and maritime industries. He's a member of the CCRM advisory board here at UC Berkeley, a frequent speaker at conferences, and participates in stakeholder groups focused on reducing the risk of maritime oil and gas operations. He completed his PhD here at UC Berkeley, developed a risk-based method for interdependent, interconnected, and interactive critical infrastructure systems. He's been awarded the Regents Fellowship, Jane Lewis Fellowship, and Excellence in Teaching. So with that, it's my pleasure to now pass the ball over to Hamed.
Thank you, Rune. It's really good to be back with you guys. I've completed my research back in the day on the resin and CCRM, collaborated with Paul, Emery, you, and tons of other folks. I feel like I'm presenting at home today. This presentation, a version of this presentation was presented at Offshore Technology Conference, but it has been modified for this crowd because I wanted to make it interactive, so you guys would reinforce my thinking, criticize my thinking, and we move forward under that notation. When we set up this presentation, the way that we started that, out of all of fields of science and technology, we go into biology, and not any kind of biology, we go into evolutionary biology. Stephen Jay Gould, a very famous evolutionary biology at Harvard, wrote a paper which eventually became a book titled Panda's Thumb. I can honestly not remember the detail of that article, but essentially what Stephen Jay Gould pointed out in that paper is that most of the birds, they have 5 claws and they are very short, versus panda, they have longer fingers and opposing thumb. And with this, they grab what they want and use it. Something happened through the history, environment changed, they moved from one location to another location, and this thumb became kind of obsolete. It became unuseful for them. So when you look at the anatomy of pandas these days, the thumb is there still, but it's rigid and it doesn't do any good for these animals. What we have done in this work is basically put on the lens of panda's thumb and looked at the organization and identified all of those panda's thumb in the high reliable organization and addressed that. Why did we have these in the first place? What was the intention of it? Through the path of this specific or entire industry, specific corporation or in the entire industry, what happened is this element of assessment is still useful? If not, why is there? And can we do something about it to make it more useful and up to date to serve the challenges of today? We have reviewed oil and gas industry, utilities, maritimes, not only their internal procedures and guidelines, also the code and regulation that they follow to get the approval from regulatory bodies to go with their planned operation. As you can see on the screen, review of these organizations brought several points to our attention. There are several strengths in terms of risk assessment. They all have a systematic approach. To a good extent, they identify failure modes and mechanisms associated with them, and they are really good in identification of those. Since it's a systematic approach, there is good percentage of acceptability among the stakeholder with this approach. As the strengths, when they have those strengths, there are opportunities. The main one is, you can get the acceptance criteria among the energy operators and stakeholders because it's a common approach. You can easily, there is a method that go from failure mode assessment to assess the probability of failure, and any future improvement can be structured around current acceptable platform. Now, there are weaknesses also which create threats to the process. Uncertainties are not fully captured in these methodologies. There is lack of uncertainties, and industry, they are aware of it and they know about it. This is based on the work that we have done. The core of the risk assessment, to a good extent, falls under a matrix, which we call it a risk matrix. Sometimes it's 3 by 3, sometimes it's 8 by 8, depending on a sophistication of the corporation or operation. But there are some challenges. The risk matrix are qualitative, and also when we are talking about technologies and sensitive, I'm focusing on the sensitive environments, it's not matching what we were trying to do because it's based on the past, and risk matrix are developed based on the past. New technologies, we don't have an extensive record related to them. It's subjective assessment based on the mitigation effectiveness. It's one organization talks differently about effectiveness of mitigation rather the other way. It's not it's a process, not a methodology. It's a checklist approach rather than methodologies can be adopted to another areas, and there is heavily depend on the subject matter experts for that process, which is good and bad in some cases. Threat that is coming from this, when we are not capturing the uncertainties, we are keep focusing on the wrong risk, assessing something that might not be there. Underestimation of the probability of failure and consequences of failure. It's minimum that we can do anything about optimization, higher capital expenditure on that, and the big one here is they all agree and they all talk about lack of capabilities in managing what they call unpredictable. They can manage the risk of predictable challenges, but when it gets to the unpredictability, they have lack of uncertainties. So this is basically a summary of what we are going to go deep dive in detail for the rest of it. So If you don't have time to stay with us, this is a good time to say goodbye, because the rest of the slides is going to be a very deep dive in each of these elements and identification of what can be done about it. All right, let's talk about managing unpredictability. In the oil and gas industry, utility and maritime industry, when we are talking about risk assessment, the basic platform for having a view, a comprehensive view of a risk is based on what we call a bow tie diagram. I'm gonna go into the detail of it, and I apologize if some of you guys they have very good familiarity with the concept, but I'm gonna go into the detail of it because in order to move to the success path, we need to understand the core part of this this bow tie assessment. On the left side of this bow tie, we are focusing on the threat and hazards. If we are doing flood risk, this is a 100-year event. This could be a seepage, underground seepage. This could be a slope stability. If we are talking in the oil and gas industry, we are talking about failure, mechanical failure of the BOPs, well casing damages, different hurricane hitting your platform. When you are in the utilities, we're talking about corrosion. We're talking about struck by an equipment. So these are the hazards that they are showcased on the left side of this diagram. If you can see all of those gray lines, those hazards are on a path to go to a catastrophic emergency event, which could be breach of a levee, it could be a oil spill from a tanker, or it could be a blowout, loss of containment. What we do in industry, we have a proactive approach. We start putting barriers in all of those paths. Some of these barriers are covering 2 paths. Some of these barriers are specific to one threat in order to block the path from getting that hazard all the way to the top event. By top event, I'm referring to that bluish emergency catastrophic event in the center. At the other side, on the right side of the diagram, we're talking about the consequence. We're saying, given the fact that this big event happens, what are the paths that leads us to the biggest case, worst case oil spill? What is the path that it would take us to burning a big neighborhood in south of San Francisco? What is the path to spraying ammonia over a sensitive environment? And exactly based on what we did on the left side, we start putting barriers in place in order to reduce the consequence of failure. Now, when we get to the unpredictability, none of these work, ladies and gentlemen. The reason is that these barriers all coming from a case, a failure, a phenomena that happened before. We learn from it. Based on our learning, we implement a barrier in place, both in the consequence and the failure assessment. If we knew what the unpredictable event would be, we don't call it anymore unpredictable event. We call it predictable when we already had barriers in place in order to minimize the risk of those. What we are suggesting to the industry is basically, in dealing with the unpredictability, you need to have your proactive approach. You have to have your reactive approach. But in the core of your interactive approach, you need to introduce set of lenses. These are barriers on the left-hand side, but at the core, you need to have lenses. As your event start to unfold, to the point that you have the full breach or loss of containment, you have time. This time could be 72 hours, it could be 2 weeks, it could be 3 weeks. You need to have a proper detection, analysis of that detection, and correction in order to get it back to the success path. If we don't do it, we are past that window of opportunities, and the failure is it's there. There's no way that we can avoid it. Based on each unpredictable event that we solve, the case history associated with that would become a barrier and become parts of a proactive approach for the future cases. Now, one thing that is core to dealing with unpredictability is understanding a proper way of uncertainties. I'm going to shift here and talk about uncertainties. This slide is very familiar for most of you guys, but for those who are new, I'll go through it in very brief summaries. The end part of this diagram that you see breaks down into the 4 main categories, 4 types of uncertainties. When we are in the domain of unpredictability, we need to capture all of these 4 categories of uncertainties properly. The type 1 is natural, or what we call that they are inherent to the system. These are different wave heights. These are different geological formation that we are tapped into in order to get fossil fuel out of it. They have different pressure, they have different temperature. This is the uncertainty associated with the material of the pipe that we use for pipeline industry, whether we put it underground or overground. These are the materials of the levees that we use when we are on the topic of flood risk and risk management. So if we don't capture type 1 uncertainty, there is one missing element onto it. The type 2 assessment is basically the models that we have out there. They are representation of the real world, but they are not real world. They are basically a snapshot in some cases of reality. So there is a difference between the models that we basically exhibit and demonstrate, whether this model is our oil spill model, whether this model is flood risk, what area of the land is going to get flooded. This is whether it's a pool fire demonstration, finite element, difference, how extensive the fire would go. But these are all basically the models, and they have uncertainty associated with that. These model uncertainties can't be reduced because as we evolve in our technologies, we have a better models with better characteristics, so it can be reduced. Whereas as type 1 uncertainties, which is natural and inherent, they do. Type 3 and 4 are the big topic, especially for CCRM, high reliability organization. The humans that they're operating in these organizations, both from the folks that they are boots on the ground all the way to the C-suite executive. There is a great deal of uncertainties with how they conduct the work, what organization ask them to do. These organizations and the risk associated with that is not only limits to corporation, it can extend it to the regulatory bodies, changing to the regulatory bodies, demands of the market, shift in our strategic view. All of these can create an uncertainties and needs to be included in our dealing with unpredictability. And last group but not least is basically the information related, information development, whether the information is there somewhere, has not been transferred to us, or it does not exist and we don't know about it. There is an uncertainty with that, which we go into the risk assessment, needs to be fully captured and covered. Now, when we go and pitch this to executive of the energy industries, whether they are utilities, whether they are oil and gas, they accept the opportunities to grow and they like the concept of managing the unpredictable. But usually, since they know that this is something out of their day-to-day business, they look at consultants, whether they are risk consultants, management consultants, external consultants to come in and basically assess this unpredictable catastrophe. What consultants tend to do, it's what you see on the left side of the screen. They go into the organization and pretty much they dump bunch of solution on their desk. It can be defect elimination, FMEA, root cause analysis, maintenance work management, planning and scheduling, inspection. But literally what consultants do, they just dump pile of solution in front of them, and they try to sell and help with all good intention, but it's just a package that is not organized. What success path here suggests is that all of these solutions are pieces of a puzzle that they need to fit in together in order to minimize the unpredictability risk. You might have all of these good solutions, but if you don't put them in the right order, if you don't arrange them the way that they needs to be, not that they don't even serve you good, they might cause you headache and frustration. People on the ground, on the platforms, the inspectors that they are looking at the pipelines, they just look at them as a checklist that it needs to be done, and just at the demand by their line manager without even knowing where this goes, what this assessment does, how it would improve, what is the KPI that it builds over that, what threshold of the KPIs we need to understand in order to flag this for better understanding and solving the issues. So I'm going to give you a couple of examples based off this package of the solution that we usually go out and pitch it to the industry, and I would say, what is the shortcoming of that? Let's look at two of them. One of them is FMECA, which is failure mode, effectiveness, criticality analysis or assessment. The second one is FDA, which is fault tree analysis. I'm pretty sure most of you guys, they have good familiarity with both of these two concepts, but I'm going to go into the detail of it to see what is each and what is the shortcoming of each of these assessments. For the FMECA, if you are looking at a blowout preventers, we basically strip down the blowout preventers into nuts and bolts, to the small pieces, and each of those pieces become a line item into several pages of a spreadsheet, and line by line we look at the failure mode, effectiveness, criticality of it, and do kind of an assessment off of that. The problem is that this is a bottom-up approach. I would even say it doesn't go even up, it stays at the bottom level. We just break it into the pieces and elements and create this magnificent source of information sitting out with subject matter experts, but in the pieces. We never put all of these component level and make it a systematic, a system level for that specific piece of equipment, whether it's a blowout preventer, whether it's a sophisticated valve that does transfer of LNG from terminal to the tankers, or even the galvanized or pipes that they carry crude oils or gas. So what we do is basically looking at bottom of approach, component level. In the fault tree analysis, it's kind of a reverse. We look at a condition that occurs, and we looked at all the possible branches that it would go out of that event without even understanding of how did event cause. Basically, you say it happens, and what are the possibilities of these 10 branches that spread out of our analysis. The best solution out of it, it's a common ground somewhere in the middle. I'm not saying that FMECA is useless. This is going to be the theme for this presentation, that we're not going to stay with one solution, because one solution wouldn't solve our issue. We need to consider a package that looked at both of them, top down and bottoms up approach for dealing for unpredictable events. The second part, the second element that I would like to bring to your attention is a good old probabilistic assessment versus your deterministic assessment. For the probabilistic assessment, we heavily rely on the data analysis, forecast, future, simulation, parameter modeling, getting the distribution. And the core of the probabilistic assessment is what if scenario running. What if this happens? What if that happens? What would you do? So this is looking at the future. That is your probabilistic approach. Versus your deterministic approach is look at the past data query, historical statistic, counting, not modeling. It's purely counting the past event. And the decision model is, instead of what if happen, what if going to happen, is basically what happened in the past and understanding of both. When we are sitting and doing risk assessment, we always have this challenge of whether we need to go probabilistic and deterministic. A good friend of mine a few years ago, Dr. Oliver Magisi, told me that it's like driving a car. You cannot say with any certainty that I'm just going to drive a car looking at the windshield and looking forward without looking at the back mirror. You also cannot claim that I always drive looking at the back camera and back mirror. Both of these are useful for your assessment. You need to find a proper place for combination of both probabilistic and deterministic model. I can clearly remember the day that we were sitting at 212 McLaughlin with Emery and Paul and Robert B. And I was presenting the probability of levee failure in Sherman Island. Our approach was probabilistic approach. We were looking at a probability of failure of the event. That day, beside these three gentlemen, we had a guest. The guest, I can't remember, was he from RD Reclamation District, or was he from a flood management group. I really can't remember. When I finished my presentation and I showcased that there is a 20 to 25% chance of failure for this specific location, he posed that question to us that, hey guys, you did a great job and did this assessment, but I look back and in the past 20 years, I had one single failure. You're saying 20 to 25%, meaning that each year there is 1 in 5 chance. But I look at my past and it's 1 in 20. We struggle to answer that. But what he was doing was looking at the frequency of events. What we were showcasing to him is probability of an event, a probability of head or tail in a draw of a coin is 50% every time, anytime, based on the assessment, based on the statistic, based on the math of it. But someone would sit back there and say, well, you know, I drew that coin 10 times and 1 out of that 10 was head. So what he's referring to is frequency. What other folks are working on it is probabilistic. With no shape or form, ladies and gentlemen here, I'm not suggesting that one is better than the other one. In one shape or form, I'm not saying one is underestimating, the other one is overestimating. If you want to deal with unpredictability, you need to have a both vision. You need to look at the probabilistic model and also your deterministic model. There is no one solution that would fit this this assessment. All right. Rune, do you want me to pause or do you want me to go, and whoever has a question, basically they would
I will defer to you. If you want to take questions as we go through the process, feel free. If people have questions, maybe what we can do is put them in the chat. Hamed, do you have the ability to kind of monitor the chat channel?
Well, I can see it right now, but there's no question so far. So I'll continue, and if anyone wants to, please interrupt me. There is no limitation here. So this is our good old bow tie that I showcased earlier. The first one was a nice cartoonish version of it that the marketing folks, they put it together for us. This is the actual bow tie that is being done for LNG bunkering. As you can see, all the hazards or threats from misalignments of the valve, in striking, impact, heat cycle equipment, overfill are exhibited on the left side of the screen. The barriers that they would avoid that hazard cause the loss of containment are set in place. If the loss of containment happens, we have another sets of barriers in place in order to avoid pool fire, flash fire, jet fire, or any sort of fatality. As you can see, when we set up these barriers, not all of these barriers are going to be owned by one entity. Some of them are being managed by US Coast Guard. Some of them are going to be managed by the Port Authority. Some of them is going to be managed by the owner and operator of the LNG facility. Some, they have joint ownership. I don't know if any of them, they know that they have joint ownership. And some of them, if you see, they don't have any owners associated with them. Now, as I was showcasing, to a good extent, we covered proactive here. We covered reactive here. But look at the core. There's nothing from the point that we have a small leak all the way to a big pool fire. We don't have any core lenses and assessment in the middle. The other challenges that we usually sit in these sessions in order to put these barriers in place is that hazard identification is it's subject matter based. I'm a big advocate of using the subject matters, but not necessarily all the time those people that they are coming to these sessions are subject matters. Subject matters, they are expensive. Subject matters, they have tens of things to do. The sessions that we put for the HAZOP or hazard assessment in order to get these barriers to these cases usually end up having folks that they are quote unquote subject matter expert, but they are the guys that they don't have anything to do that day or that week. Frequencies. Everything in this is frequency. It's not probability. It's based on what they have observed. They don't know anything about possibility of what can be occur. Then some of them, it's even not even frequency. It became qualitative. It became just high, medium, and low. Have I seen it at low? Have I seen it? Yes, medium, couple of times. It becomes a qualitative assessment. Mitigation effectiveness, it's a tough one here. We talk about mitigation effectiveness, but it's all based on knowledge of subject matter expert. We have good models out there that they can talk about mitigation effectiveness, but when that result gets into the overall big picture of risk assessment, it doesn't really fit, or they don't usually use it. It ends up being a very rough estimation of the effectiveness of the mitigation. So even when you set up a proper, which I'm a big advocate of the bow tie. I think whether we are doing flood risk, whether we are doing oil spill, whether we are doing fire and explosion, we need to have a bow tie exhibiting all the threat and hazards and associated barriers with them. But we need to understand that when we go and sit with the corporation, these are the shortcomings to an extent of these this assessment. Now, as I said, this is a presentation that I did for offshore technology conference, but I modified it because audience here are mostly from California, and I might be an interest that we talk about wildfire caused by basically wildfire mitigation plans that it's put together by utility companies every year when they file their rate cases and submit to CPUC. There is a concept called risk spend efficiency, RSCs, and that is a fundamental core of the wildfire mitigation plan risk assessment. There is 3 core categories associated with assessing that RSC in the wildfire mitigation plan. They look at the mitigation and they break it into the 3 main categories: the direct wildfire risk, the PSPS risk, power shutdown risk, and also the mitigation that they are dealing both with wildfire and PSPS. The mitigation that they put in place in order to eliminate wildfire risk heavily focus on probability of failure, the chance, the percentage that it would reduce that risk. And also they talk about effectiveness of that. Also, they look at the lifetime benefit, the capital expenditures related to that, and O&M expenditure associated with that. And they do a calculation in order to get the risk spending effect. When we are in the power shutdown, PSPS, those mitigation are focusing on consequence of failure. And then we need to understand the effectiveness of that, which it's a wild west when we're getting to the effectiveness of those measures, because it becomes my word against your word. And then last but not least is those mitigation that they are focusing both on wildfire and PSPS, which is probability of failure and consequence of failure. We assess the probability and effectiveness of all of these mitigation. We also look at the cost associated with both of these. What we end up doing is basically compare the risk reduction versus the cost of that specific mitigation, not the cost of consequence, the cost of that specific mitigation. If we implemented a new capacitor that it wouldn't fail and it would create sparks, that's the cost, not the cost of if it fails and cause fire. That's the cost. The cost associated with that, it covers on the consequence of failure. Now, and we assess the risk spend efficiencies. All the utilities in California, they have a due date. They put these RSCs and they file it to CPUC, and every year there is a big back and forth between utilities and CPUCs. There is a big element missing here. We talk about risk reduction, and nobody, neither in utilities, nor in the commission, nor at the people that I read their documents that review these things, talk about acceptability, the threshold of acceptability, where this risk starts and where we brought it down. Was it even down and we brought it down more, or was it high up? No one look at the big picture. We're just looking at line item, mitigation by mitigation, assess the risk, assess the consequences of it, and then issue the risk spending efficiency factor. No one said, let's step back, look at the big picture, where we are at and where we are going. Maybe some of these mitigation, they're already below the ALARP or acceptable zones. Let's focus on the ones that they would actually reduce the risk. But as of now, this is the practice, and there is a big improvement that it needs to be done for this assessment. And hopefully folks in California, the folks that they are collaborating with CPUC, it's a good opportunity for CCRM to help them advancing with this challenge. Now, success path. We looked at all of these, I don't want to say flaws or shortcoming, but we looked at all of these these methodologies, and how we saw that we can improve them or join them together in order to get an improvement. But now we need to look at what success path is. Traditional risk assessment, we look at each of the process of all of our activities, whether it's plan, schedule, design, build, service, maintenance. We put the process together and we start assessing risk. But we look at these processes 1 through n for each of those boxes individually. Whereas in reality, environment change, regulatory change, there is a war, there is tons of activities that happens when you're in the scheduling phase. The design would start. When you're in the design phase, you need to start building a line of a pipeline, or extend your LNG trestle, or move carriers into your fleet. So risk assessment, box by box, individual process doesn't work. Success path, what success path suggests is that we need to look at the business output, where we want to go, how actually the work gets done. We're going from step 1 to step 2. It can fail from 150 different ways. What we need to do is that, what is the risk of getting from point 1 to B. And if it fails, what we can do that immediately with the minimum impact, bring it back to the line of business, bring it back to the operation, go to the extreme and get it done. The focus doesn't need to be, I'm not saying that we don't need to focus on the 150 ways that it can fail. The focus needs to be on that if it fails, what can we do in order to bring it back to the track, to the critical path that is vital choke point of this operation. When we are looking separately, we look at the mechanical failure versus the elements that dealing with the human factor, process, people. When we are looking at the success path, all of these merge together. They are points that they are overlap. There are points that they have nothing to do with each other. Some of these processes, they exactly the same. So looking at a silo vision, box by box, doesn't do it. We need to look at the end business outcome, where we want to go, where we want to do, what are the tools and techniques that we get to the place in order to get from each of these steps that we are going to take in order to have a successful operation. All right. Success path breaks down into 4 levels. We call it L1 to L4. In L1, we define the scope. In the characteristic of the system, I put some terminologies like operation, organization, environment, some of the terms that might be familiar with the CCRM colleagues, but you can characterize the system in any way or form. These are just examples of it, but you need to define the scope and characteristic of the system. That system would serve as building block, as system characterization at level 1 at the bottom of this hierarchy. We go to the level 2 and define activities associated with each of the outcome. As I said, what are the outcome? What are the activities? How actually the work is going to be get done. On top of that, we are developing a lenses. We put sets of lenses. We call it L3 data lenses. Now, the data would come from normal rate of malfunction, performance shaping factor, probabilities of proper detection, analysis, correlation, distribution. All of those needs to be linked with each of your activities. And when you are walking on your success path, on the top of that, you don't need to look everywhere and anywhere. You need to know about anywhere. You need to look at the characteristics that you are dealing with, whether it's a 2 characteristic, 1 characteristic, 5 characteristic, activity related to that, the data that you need to capture from that, and basically take a step one at a time based on the information that you have, activity tiles that they are in front of you, and move forward in order to complete your task with completely managing the unpredictable events. This is a example of that. As you can see on the top, these are the characteristics. L1, plan, schedule, build, service, maintain. Underneath of that, we look at the interaction that enables the top value. Basically, plan, you talk about established brand. Schedule, you're talking about generation of the idea, identification of technologies, all of their subcategories. And when you move down, you look at the activities, logical grouping of the activities from different business units. That I'm again focusing on that, how the work gets done from point A to B, what we can do in order to manage the unpredictability. If an unpredictable event occurs, how we can quickly get back on track and minimize the consequences of it. And at the very bottom of that, you set up your lenses of analysis. Again, as I said, this is both focused on the consequence, probability, data that is coming from related to the risk, and also time and cost associated with each of these activities. So this is a simplistic view of what needs to be done end to end across the organization in order to set up a critical paths for the success, identified all the choke points, the data that is coming from that, with not elimination of all the other activities or all the other things that they can go wrong, but more focus on the critical path, more focus on the way that we can go from plan all the ways to the getting it to the service and future maintenance. And that's how it usually be demonstrated. These are some basically advantages of success path. There is an analytical framework around it. It's based on the value creation. We identifies related activities to the success path. We focus on the linkage and relationship of all of these organization, business units, people that they are working in order to get the work done. We look at it as a dynamic view. It doesn't need to be a snapshot of time. It's a dynamic view of how the works is going to be done. How if a challenge occurs, if something unpredictable occurs, how we can manage it, how we can get it back on track. And its magnification is basically directly on the outcome, how we can successfully execute the tool. Rune, I'm gonna stop here. I have one slides about digital and how digital, the new era of the digital tools and techniques would help us in unpredictability, managing unpredictability. But I don't know if you want me to cover that or stop there, see if there is any questions. I'm open for any suggestion at this point.
Yeah, why don't we do a check-in with the group? If people have questions, let's see what's going to be the best way to manage the group. You can raise your hand or maybe put your question into the chat, and then we can read down the chat list. Don't all raise your hands at once. Eric, I see that you posted a comment here in the chat. Did you want to follow up with a verbal question?
Well, I just wanted to briefly say again, so I work for the state of Oregon, and looking at slide 8, the detailed bow tie diagram, you mentioned that there were some items that might not have owners. And it looked to me as though one of those items was emergency response and evacuation. And I suspect that item may have an owner, just not an owner who's a participant in the regular process as it was described. Is that right?
Absolutely, absolutely. But again, that was a shortcoming of our hazard session, because when we went over there, we asked all the stakeholders to be participant. But when we get over there, there was no owner for that. Everyone was looking at the other one. But you're absolutely right. There is an owner. But when we are in the risk assessment session, the SMEs on that topic wasn't there. That was just an example of it. It always happens when we go. There is one or two barriers that they left orphaned, and no one knows. Everyone start looking at each other. Then we have to dig deep to find out. Oh, there is this stakeholder that wasn't invited to the party.
Thank you. I appreciate that.
All right. I see one question. Emery asked that if this process reduce the overall risk of failure, it's reduced. We are in Emery. I would characterize it as we are in the damage control phase at this point. When we are getting to that core, when we are getting to that top event, we pass basically the probability side of the shop. The probability is basically 1 at that point. The sucker it failed. Now, from that point all the way to the full breach or full spill, we have time to minimize it, and it would reduce the overall risk, but not probability, just the failure rate or probability of failure. I don't know, Emery, if I addressed that question correctly or not.
Hamed, can you hear me?
Yes, I can hear you right now.
Yeah, I think this is a really great presentation, and I'm just going to have to look at the slides and think more about it. But I guess the question that I have is, go back to the bow tie, go to the failure. There you have detection, analysis, and correction. And what happens if when you get into the failure at the correction, analysis, detection, and all your lenses are the fog of war? All your lenses and detection analysis tells you in a more, and this is my terminology, but it's a way to sort of shove me to sort of look at yours as a way of answering it. In my terminology, all I see when in a magnitude 9 earthquake in Oregon and Washington is, if that is a magnitude 9 and happens as they tend to predict, at the moment it happens and in the next 5 to 10 minutes, what you will see is basically non-measurable uncertainties accompanied by disproportionate effects. I mean, you will see things that you know are an earthquake, but it's all non-measurable, and it's all uncertainties 1 through 4. And accompanied by doesn't even mean causal or correlative. These disproportionate effects will be measured against what emergency managers, experienced ones, have seen before. And this is nothing like they've seen before. They've seen more fires, they've seen more ice storms, they get a sense of operating blind, but this is like disproportionate. So anything you can do to, now to get to your point, when I take over your story, anything that you're doing seems to be a good advantage. You know, you're immunizing yourself with failure. As you go along, you expect it, or minor mistakes, or some things don't work. You come and try to build up, if you will, an immunity to failure, so that when you get to this middle, the M9 has occurred, you're in the first day, you're in obviously an emergency response, but you just are, everything is non-measurable and everything is disproportionate.
Emery, it's great point. We usually say if it's beyond measurable or unmeasurable, let's give it the benefit of the doubt that it's occurred. It's a probability, it's 1. Now let's think about what you can do after that. Yes, there are certain things that we can assess and manage, and come up with a number for it, or qualitative assessment of it. But there are certain things that, as you said, is beyond measurement, beyond assessment. We always said that let's run a case scenario without even assessing the probability of it, that this thing happens. What do we have? What measures do we have? What is the early stage of activities that we can put in place in whether it's 5 to 7 minutes, whether it's 7 to 10 hours, or whether it's 7 to 10 days to basically bring it back to the critical time. At that point, the focus of the detection and analysis and correction, it's not more of a mathematical or calculation activity. It becomes more of a, now that it occurs, now do we have all the right tools, corrective tools, analytics related to correction measures in place in order to get it back on track. That's the morale of it. Yeah.
Thanks. That's great.
Yeah.
Hamed, I know that you said you may have another meeting in a little bit, so.
I have another meeting in 15 minutes. I just wanted to bring one thing to this group of excellence here, that they think about it. When we are in a new era, then left and right corporation are implementing digital tools and techniques, whether it's because of the COVID or because they wanted to be on the forefront of advancement. They like adaptability of the new technologies. When it gets to the risk assessment, we need to be very careful about all of these tools and techniques. We need to categorize which tool, which digital solution, which data assessment falls under the detection side of the shop, which side of them what falls under analytic part of the shop, and which part of them help us with the correction factors. It wouldn't suit best any organization, any corporation, that they just say that we are on the avant-garde side of the activities, and we're just going to adapt any new digital solution into our operation. It needs to be a structured way of each of them being implemented. You can't implement a digital correction solution into your operation in order to minimize the risk of wildfire and go out there and show the public that there is an application or there is a VR out there without having a core integrated platform, a data backbone, a analytical fundamental underneath of that, which you can basically reduce your risk. You can't have advanced artificial intelligence or machine learning in your analysis without a proper platform and data storage that can handle that. So if you see, or if you guys out in whatever you do, you see folks that they are pitching some sort of a technology that demonstrates that it would reduce the risk, I would argue that you can challenge them to see if they have proper fundamentals in place. Are they looking at it just because of a cool tool to be in their toolkit, or is it just really they thought correctly about it in how this would aligns with their other risk mitigation measures in place. So that was my last slide, Arun, which I thought it would be useful for the folks, especially in California, to think about it.
Yeah, no, that's great. A larger philosophical question for you, Hamed. There's what we know about yesterday, but looking off into the future is something we may or may not know something about. So these would be uncharacterized hazards. When we do the quantitative risk analysis, do you have some sense of what % of the total risk exposure you're actually calculating, right? This is the kind of in the known universe versus the things that you don't know about yet. People mistakenly believe that if you do a risk analysis, it's calculating 100% of your risk portfolio, which is not the case. What's your sense of what % of your total risk exposure we're able to quantitatively analyze?
Great question, Arun. And I'm 100% with you. When we are doing the risk assessment, we are not fully covering everything. I'm not saying that safety, environment, enterprise level, not in that. Even when we are talking about safety, when we're talking about environment, whether we're talking about loss of reputation, we always look at a portion of that. And that portion, if we do a good job, even if we do a good job, is based on the lesson learned that we assessed before. A large portion of it that caused the failure in the future, it's always based on the things that we don't know, or we never thought about it. This is a very a small portion of it. Let me give you an example. When the shuttle program in NASA started, they said the probability of failure, they did, I mean, I can assert that those guys, they know how to do the risk assessment better than everyone. When they did the risk assessment, they said the shuttle failure probability of failure is 10 to the negative 4, 1 in 10,000. I think Challenger was 1 in 25. Which one is wrong? Nothing is wrong. They probably just look at the portion of it and they say, oh, it's 1 in 10,000. Whereas reality, they didn't cover a big chunk of it, which ended up showcasing the number is 1 in 25. I can't give you a definite number, but I can definitely tell you when we do this risk assessment, a big portion of it remains unassessed. That's why I keep saying the word is risk assessment and management. If you can't be able to assess it, if you leave a portion of it unassessed, think about management part of it. Let's not get involved in the assessment, go back and forth, on those sort of conversation. Let's say, okay, given the fact that this thing happens, we did the assessment and it's 10 to the negative 4. Let's now have a conversation around that. If it's a probability of 1, what we can do about the management part of it. So that's how I usually frame it when a good question like that comes across.
Great, no, thank you. I
Hamed.
appreciate the feedback. Emery.
Yeah, to pick up on Runes, I think what you're, again, taking over what I'm hearing you say is, I think we have to have a much greater differentiation of these unknown unknowns, these under-acknowledged hazards, because the stuff that, if we're able to have a system that recognizes there are latent risks that become manifest only in failure, then you are on the way to better understanding unknown unknowns. If in fact you have detection, correction, your set of lenses, you're better able to say, well, here are a set of interconnectivities that pose a whole set of latent hazards that we know about, we can't even model about, until they happen, until the risk manager gets to say the morning after, well, now that we know what we're left with, this is what we have to do. Okay. Yeah. Now that is not a lesson in futility, but it would, and then I sign off here, say that one thing in a longer presentation or the next presentation is a much more finesse on this notion of interconnectivities. and latent to manifest risks, hazards, whatever you want to call them.
Yep, agree.
Thanks much.
Thank you, Emery. Good to see you.
Well, great. Thank you for a wonderful presentation. We look forward to hearing more from you in the future. And thanks to everybody for joining the workshop or the seminar today. We will likely be taking the next couple summer months off and then starting up again either in August or September. So with that, thanks for joining and have a great rest of the day.
Thank you, everyone. Really appreciate it. Bye.
Thanks. Thank you.